Hey guys, Travis Gillespie here. Today we're going to look at comparing perimeter and area. In this first example it says, find how the perimeter and the area of the figure change when its dimensions change. So let's go ahead and highlight that word perimeter. We know that's the distance around the shape. Let's go ahead and highlight the word area. That's talking about how much space the shape takes up. And then we're going to also highlight that word dimensions. And dimensions is just saying, hey, the values along the side of the shape. So let's look at those dimensions. Well, this dimension would have to be 1, 2 units in width or in height. So I'm going to plug a 2 in. And these dimensions along the length here, or the bottom, are 1, 2, 3, and 4 units. So I'm going to plug a 4 in. And along the top, it's 1, 2, 3, and 4 units. So 4 again. And let's fix that 4 because that's a little bit sloppy. And we also know, without even counting, that this last side has to be 2 because this is a rectangle and the other side previously was marked as 2. So I'm just going to write another 2 down. Okay, so we have all of the lengths or the dimensions of this shape, the rectangle here. Let's go ahead and take a look at this other shape to the side. And let's also take a note of asking ourselves, what's happening from the original shape when we transfer over to the new shape to the side? So what's happening as we transfer over to the new shape? Well, the new shape's being reduced in size, and let's take a look at its dimensions. Well, this is 1 unit. This is 2 units along the bottom. That means it has to be 2 units along the top and 1 unit along the other side. So what's happened here? Well, we've reduced the size of the original shape. So let's go ahead and make a couple of notes real quick. We can either make shapes larger in math, or actually even in the real world, take objects or figures or shapes and make them larger, and we can also make them smaller. Now in math we have terms that we use when making objects or shapes or figures bigger or smaller, larger or smaller. So let's talk about the larger ones real quick. Well, when we make them larger, in math we either say it's being enlarged or it's an enlargement. Let's just fix that arrow. So I'm going to write that word enlarge. We'll fix that E as well. And now let's also say, hey, you know what, another way of saying this is we can dilate the shape. And a dilation, just think of your pupils real quick. It's when you're, if you were to walk outside and let's say it's dark outside, your pupils will dilate because they are getting larger so that more light can enter into them. So dilation is when objects are being enlarged. But we can see here, this object here, it's not being enlarged, it's not being dilated, it's getting smaller. So therefore, we know it is going to be a reduction in size. So in math we call this reduction, or we can just say reduce. So we've reduced the original figure to a smaller figure. Now there are also operations that go with making objects larger or making objects smaller. So let's talk about those operations. Well, if we make them larger, if we enlarge them or dilate them, we're going to use multiplication only. If we're making an object smaller or reducing it, well, we're going to do the opposite of multiplication, which is division. So if we look at this first shape, which is larger, we're going to reduce the size. That means mathematically we've got to divide. So let's go ahead and just write division below. We're going to use a division sign, and next I want to just look at one of the dimensions, which happens to be 2 in this case, 2 units. How did we get from 2? Let's look on the corresponding side on the other shape and ask ourselves, what's this value? Well, it's 1. How did we get from 2 to 1 using division? Well, we had to divide 2 by 2 to get to 1. So 2 divided by 2 is 1. So basically we're dividing this side length by 2. Also, let's take a look at what happens when you take this bottom length, which is 4 units. How did we get from 4 units to the corresponding side, which is 2 units? Well, we have to take 4 and divide by 2 again. So we're taking all of the dimensions along this rectangle and dividing them by 2 to get our smaller shape. So now let's go and find the perimeter of this first shape. So I'm going to add 2 plus 4 plus 2 plus 4. The reason I'm adding all of these values to find the perimeter, all we have to do is add up all of the side lengths. So the perimeter will be equivalent to all of these sides being added together. Well, 2 plus 4 gives us a value of 6, and 2 plus 4 gives us a value of 6. So 6 plus 6, well, the perimeter has got to be equivalent to 12. Don't forget your units, so let's write that word, units, down. So the perimeter of this first rectangle is 12 units. Let's find the perimeter of this second rectangle. And what I want to do is just make a little dividing line here and choose a new color. So the perimeter of the second shape, I'm going to add 1 plus 2 plus 1 plus 2. So 1 plus 2 plus 1 plus 2. So this has to be 1 plus 2 is 3, and 1 plus 2 is 3, and 3 plus 3 gives us a value of 6. So the perimeter here is equivalent to 6 units. All right, now I just want to make a little bit extra room here so that we can get a better, just some more room to work. And let's find the area of both shapes. So now we're looking for the area. The first thing I want to do when working with area is write down the formula for the shape we're dealing with. Since we're dealing with a rectangle, the area of a rectangle is equivalent to the length times the width, or you might like saying base times height. Either one works out. So I'm going to take 4 for the length and multiply it times 2, which is the width. Okay, so 4 times 2 is equivalent to 8. So we have 8 units in this case. Since it's area, we're going to square it. So I'm going to write the area is equivalent to, let's fix that equal sign there. The area is equal to 8 units squared. Cool, so let's go ahead and just box this information up. We're going to box up the area, it's 8 units squared. The perimeter, it is 12 units. Also on the other side, let's box up 6 units here for the perimeter. Okay, so let's go ahead and find the area for the second rectangle. I'm not going to rewrite this formula for the rectangle because I've already done it right here to the side. So let's just go ahead and take 2, the length, and multiply it by the width, 1. So 2 times 1 in this case. And 2 times 1 gives us a value of 2. So the area is equivalent to 2 units squared. Let's box this information up. Okay, well, we found the perimeter of both shapes. We found the area of both shapes, but we haven't even really answered what this question's asking us, and it's saying find out how the perimeter and area are actually changing when the dimensions are changed. Well, remember earlier we noted that we are going to reduce this figure by dividing by 2. Let's go ahead and take this information, division of 2, and we're just going to write off to the side, just make a note that we changed the dimensions, all of these dimensions, these side lengths, by dividing by 2. So we're going to write division of 2 here. Now before we move forward here, I just want to make some notes off to the side. I'm going to make one more divider, and let's ask ourselves, I'm going to show you 3 things we're going to look at in this chapter. We're going to look at perimeter, that's a capital P. We're going to look at area, that's a capital A. And we're going to look at volume, that's later in the chapter, capital V. Well, whenever we deal with perimeter, we always deal with units. Just it's one dimension here. You could think of this as units to the first power. I'm going to erase that one because we never put it in place. Well, what's going to happen to area? How do we always write the units for area? We always write them as units squared because it's units times units. And then volume, we're adding an extra dimension, and I bet you can guess how we write our units out for volume now because we're essentially moving from 1 down to 2, and now we're moving to 3. So units, we'd call this cubed. We're not even going to look at volume. I just want you to get a heads up and just an idea of what's happening in the future. But understanding perimeter and understanding area, how we write these units out, will help us in understanding how the dimensions change when you're either enlarging or reducing objects. So let's look at perimeter over here. What happened to the perimeter? Well, how did we get from 12 to 6? Remember, you can only multiply or divide. Since we're reducing the shape, we're going to divide. So 12 divided by 2 gets us 6, and we've already written that down for the change in the side lengths or change in the dimensions of this shape. So whatever you're changing the dimensions by, the same thing will happen to the perimeter. So we would just make a note, the perimeter, and I'm just going to write P to keep it short, is divided by 2. Now, if you were in a math class, they'd probably want you to write out a full sentence. And now let's just take a look at area. So I'm just going to bring that division symbol down and that number 2 down. So we're going to divide by 2 here. And now let's actually look at the area. Well, if I took 8 and divided by 2, I should get 4, but the area of the other shape is not 4 units squared, it's 2 units squared. There's a mistake in this math right here. I cannot just write division of 2. In fact, I should probably put a capital A here. So the area cannot just be divided by 2, but let's ask ourselves, what do we always do with the units for area? We always square them because we're dealing with units by units. So what would happen if we actually squared this value here, 2 squared, which is the same as 2 times 2, which is equivalent to 4. So let's look at this as being divided by 4. So go back down to that area of the original shape. If we divide 8 units squared by 4, well, we get 2 units squared. That checks out. So how do the perimeter and the area change when you change the dimensions? Well, the perimeter of the original shape is divided by 2. And the area of the original shape is divided by 4. Cool stuff. Let's box this up, and I'll see you in another problem, guys.